Imagine a spacecraft traveling through space at an incredible speed, knowing that one day its journey would end inside the planet it had spent years studying. That spacecraft was Cassini. Launched in 1997, Cassini began one of the most ambitious missions ever sent to the outer solar system. Its destination was Saturn, the giant ringed planet that had fascinated astronomers for centuries. But what scientists discovered there was far stranger than they had expected. Cassini did not reach Saturn quickly. The spacecraft spent 7 years crossing the solar system, using the gravity of several planets to increase its speed and conserve fuel. In 2004, it finally arrived at Saturn and entered orbit. What followed was 13 years of exploration. During that time, Cassini completed hundreds of trips around Saturn, photographed the planet and its moons, and gathered an enormous amount of scientific information. But among all its discoveries, one tiny moon became especially important. Its name was Enceladus. From a distance, Enceladus looked like an ordinary frozen world. Its surface was covered in bright ice, and because it was so far from the sun, scientists expected it to be cold and inactive. Then Cassini noticed something extraordinary. Huge plumes of material were shooting away from Enceladus's southern region and disappearing into space. These were not simple clouds. They contained water vapor, ice particles, salts, and organic compounds. The discovery immediately raised a major question. How could a small frozen moon be producing so much water? Cassini eventually flew directly through these plumes. The spacecraft analyzed the material and discovered evidence that Enceladus has a large ocean hidden beneath its icy surface. Even more interesting, some of the particles suggested that chemical reactions were occurring deep below the ice. On Earth, similar chemical environments exist around hydrothermal vents on the ocean floor. These places are dark, extremely harsh, and completely independent of sunlight, yet microorganisms can survive there by using chemical energy. That possibility changed the way scientists viewed Enceladus. Maybe an ocean did not need sunlight to become potentially habitable. Maybe heat from inside a moon could provide enough energy for chemistry associated with life. And Enceladus appeared to have several of the ingredients scientists would want to investigate: liquid water, organic chemistry, and sources of chemical energy. Cassini later detected molecular hydrogen in the plumes. That finding was especially interesting because hydrogen can serve as an energy source for certain microorganisms on Earth. Cassini still did not discover life itself. But it found something almost as important for future exploration. A place where scientists could seriously investigate whether life might exist beyond Earth. And Enceladus was not the only surprise waiting at Saturn. Cassini also explored Titan, Saturn's largest moon. Titan is unlike almost anywhere else in the solar system. It has a thick atmosphere, clouds, rain, rivers, and enormous lakes. But there is a strange difference. Titan's weather system does not revolve around water. It revolves around methane. Because Titan is unbelievably cold, methane can exist there as a liquid. It can evaporate, form clouds, fall back to the surface, and flow through channels into lakes and seas. When the Huygens probe descended through Titan's atmosphere in 2005, it became the first spacecraft to successfully land on a world in the outer solar system. The pictures and measurements revealed a landscape that looked strangely familiar. There were rounded stones, channels, and features shaped by flowing liquids. But instead of Earth's water carving the landscape, Titan's liquid methane was doing the work. Titan also contains complex organic molecules in its atmosphere and on its surface. Scientists became interested in the Moon because its chemistry may provide clues about how complicated molecules can develop in environments very different from Earth. Cassini had turned Saturn's system into something much more than a collection of distant worlds. It had revealed oceans beneath ice, alien weather, strange chemistry, and environments that forced scientists to rethink where life could potentially exist. But the biggest surprises were still ahead. Because Cassini had not only come to study Saturn's moons. It was also going to change what we thought we knew about Saturn's famous rings. For centuries, Saturn's rings were thought to be ancient structures that had existed almost as long as the solar system itself. They looked permanent. They looked timeless. But Cassini's final phase of exploration challenged that idea. Near the end of its mission, engineers sent Cassini into a dangerous region between Saturn's inner rings and the planet's upper atmosphere. The spacecraft had never traveled through this narrow gap before, and scientists did not know exactly what it would encounter. This series of dives became known as the grand finale. Cassini survived the first passage, and the measurements immediately began revealing new information. The region between the rings and Saturn turned out to contain far less debris than scientists had expected. That allowed Cassini to make extremely precise measurements of Saturn's gravity. Those measurements helped scientists calculate the mass of the rings. And the result was surprising. The rings appeared to contain much less material than would be expected if they had been around since the formation of the solar system. Their bright, icy appearance also suggested that they had not been exposed to space debris for billions of years. Instead, scientists estimated that Saturn's rings could be relatively young on a cosmic timescale, possibly forming only tens of millions of years ago. That means Saturn may not have always looked the way we see it today. The spectacular ring system could actually be a temporary feature in the planet's history. And it may not last forever. Material from the rings is gradually falling into Saturn's atmosphere, a process sometimes called ring rain. If this continues, the rings could eventually become much thinner or disappear altogether. So humanity may be observing Saturn during a brief chapter of its history when its famous rings are especially prominent. But Cassini still had another mystery to investigate. Saturn's magnetic field. Magnetic fields are generated by processes deep inside planets, and scientists can use their behavior to learn about planetary interiors. Cassini's measurements revealed something unusual about Saturn. Its magnetic field is remarkably aligned with the planet's rotation axis. That created a serious problem for scientists. The slight tilt normally seen in planetary magnetic fields can help researchers determine how quickly a planet rotates beneath its clouds. But Saturn's unusually symmetrical field made that measurement much more difficult. After years of observations, scientists still faced uncertainty about Saturn's exact internal rotation rate. A spacecraft that had spent 13 years studying Saturn had uncovered a mystery hidden inside the planet itself. Then came the final days. Cassini's mission was never designed to continue forever. Eventually, the spacecraft would run out of fuel needed to control its orbit. Allowing it to drift randomly could have created a serious problem. Saturn's moons, especially Enceladus and Titan, had become scientifically important places in the search for potentially habitable environments. Scientists did not want an old spacecraft carrying material from Earth to accidentally collide with one of those worlds. So the team made a difficult decision. Cassini would be deliberately guided into Saturn. Before the final maneuver, the spacecraft continued observing Saturn and its moons. It gathered some of its last measurements and captured final views of the system it had spent so many years exploring. Then, on September 15, 2017, Cassini entered Saturn's atmosphere. As the spacecraft descended, its thrusters worked continuously to keep its antenna pointed toward Earth. For a short time, Cassini continued transmitting scientific information. Then the atmosphere became too strong. The spacecraft could no longer maintain its orientation. Its signal disappeared. After nearly 20 years in space, including 13 years around Saturn, Cassini's mission was over. But the spacecraft's disappearance did not mean the discoveries stopped. The enormous amount of information Cassini had collected continued to be studied by scientists. Data from Enceladus, Titan, Saturn's rings, and the planet's atmosphere continued to reveal new details. And perhaps the most important legacy of Cassini was not a single photograph or measurement. It was the new question it left behind. Before Cassini, the distant outer solar system was often imagined as a cold region where life was unlikely. Cassini changed that picture. A frozen moon could hide a liquid ocean. That ocean could contain organic chemistry and sources of chemical energy. A world far from the sun could have rivers, rain, lakes, and seas. And places that looked lifeless from a distance could turn out to be some of the most scientifically interesting environments in the solar system. Cassini did not prove that life exists beyond Earth. But it showed us where we should start looking. And that may be the